Hello everyone, once again welcome to our channel Physi Dive, and this is your teacher alexi Rajan. Today we are here with a new topic for class 11 NCERT, that is relative velocity in one dimension. So we'll see what do you mean by relative velocity, what are the mathematical equations related to relative velocity, as well as how to solve and what are the concepts related to relative velocity. So without wasting time, let us dive in straight to the class. So to the class. What do you mean by relative velocity? So before starting the class, I will show you a small video. And okay, I hope that you had seen the video there. Then you can see that I am sitting in that car and I can see another car which is moving in front of me. Okay, so here you can see that my car will be having a velocity, or our car will be having a velocity of v1, and the other car is having a velocity v2. Okay, and I am sitting here inside this car and I am seeing the other one moving. So here the thing is that we feel that if both cars are moving in a straight direction, then I can feel that this car is either moving in a slow pace, or either it is moving in a fast pace, or in a different velocity. But if you can see that if I'm stepping out from the car and I'm standing here, and the same car, this car is surpassing me, then I can see this car is having a different velocity. The scenario in which I am sitting inside the car and I am standing outside the car and I'm seeing another vehicle which is surpassing or moving, then it feels that both the cars or both the scenarios have different velocity v2. That means once I'm sitting here inside, v2 will be observed differently, and once I am standing outside, I can see this v2 is entirely different. We need to study about a very important term, that is frame of reference. Here, motion is relative. If I'm sitting inside the room, you can see me, you can see that I am in rest. But can you say that actually am I in rest? No. If you are seeing me sitting in my office, here is me, okay, and you are seeing here, you are standing here and seeing me, then you can say that I am in rest. But if I'm saying that, okay, I'm just taking you to Mars or moon, okay, so the moon is here, okay, this is the moon, and I am taking you to this moon. Now you are standing here and seeing me. Now what about me? You can see I am in this beautiful world, in the beautiful earth, and you can see somewhere in India, somewhere this part of Kerala, and somewhere in this part of Kollam, you can see me there sitting there and revolving, because earth is revolving. So you can see, sorry, the earth is rotating and you can see me moving. So here in one frame of reference, you can see I am in rest. In the other frame of reference, you can see I am in motion. The same thing happens here. That is, the frame of reference changed there. In the first scenario, the first example of this car, you can see that in the first car, I am sitting here inside the car and seeing the second car. And there will be one velocity, or velocity v2 with respect to v1, while I am standing somewhere here outside the car, or ground. So what happens there? In the ground, my velocity is 0. I am in stagnant position. So with respect to the ground, I am seeing the second car and it will have entirely different velocity. So here comes the idea of relative velocity. So how we can solve this relative velocity case? So we have seen that relative velocity, a very important term, that is the frame of reference. Same way, just have one more concept, that always find the relative velocity or velocity of an object with respect to the ground. You are taking ground as the reference point. So ground will be the reference point and you are finding the velocity with respect to the ground, as we are taking earth as the frame of reference, our common frame of reference. So here, once again, just imagine that if I have a car and if I am moving in a velocity or speed of 30 kilometer per hour, then this 30 kilometer per hour is a speed with respect to the ground. Okay. So it is the speed with respect to the ground. You can see that in the speedometer, it changes from time to time as you accelerate, as you decelerate, then you can see the speed changes or velocity changes, and then we say it as the relative velocity with respect to the ground. And if another car is moving, then definitely you can see that this car, if I'm sitting here inside this car A, and I'm observing car B, then the velocity, just imagine that the velocity of B can be stated as velocity of B with respect to A. That is, I am taking this A as my frame of reference. So this is my frame of reference, and I am just observing the second car with respect to this one, A. And I am having this denotation, that is VBA, which means that velocity of B with respect to A. And what does this means? VAB. VAB. So just opposite, that is velocity of A with respect to B. Where small kids, we usually have one particular doubt. Where we are traveling with our parents in a car or a bus or any vehicle, you can see that on the roadside, you can see small trees will be there. Okay, small trees will be there, and you are just observing. If you are observing the tree, and if this is a car in which I'm moving, and my dad is with me, okay, I'm just moving, then I'll say to my dad that, dad, why these trees are moving towards us? Or sometime, why these trees are moving towards me? Okay, so while you are inside the car and if you are observing outside scenario or things, then you can see the things are coming towards you. Okay, while you're studying this relative velocity, definitely you should have some sort of perspective changes. Okay, that means you should think in a different way. Perspective should be different. Why I'm saying this? Because you can see, if I'm saying that I am moving forward, I can also say that on my perspective, I can say they are coming towards me. That is, the trees are coming towards me. If I'm just seeing that, okay, the actual scenario is that I'm moving forward, but you can also consider that the trees are moving towards me. That means the velocity, once we are considering the velocity, then definitely velocity is what? It's a vector quantity. So velocity is a vector quantity, so vectors will comes into play. Okay, then here VAB means what? The velocity of velocity of A, this car with respect to the second car. Or we can say, if this driver is turning back or any co-passengers are just turning back and seeing you, then they can also see that your car is approaching them with a different velocity. So this is VAB. So make sure that the denotation are clear. Okay, so this is a case of relative velocity. So in the first case of VAB, VAB means what? The velocity of A with respect to B. That is, it can be solved by this particular equation, that is VA minus VB. And what is this VA and VB? VA and VB are the velocities of the corresponding objects with respect to ground, or simply we can say AG, BG. Okay, so you can say that this is velocity of A with respect to ground minus velocity of B with respect to ground, and that is denoted as this one. Okay, so here the same scenario can be taken. Okay, if this is object A and if this is object B, then what is this VAB? That is velocity of A with respect to B. That is, you are observing the object A from which one? B. So what is the thing? That is VAG minus VBG. That is, you should find out the velocity of A with respect to this particular ground minus velocity of B with respect to this particular ground. Then you will get what? VAB. That is, VAB means velocity of A with respect to velocity of B. The vice versa is also true. That is, BA means what? Velocity of B with respect to A. That means here what happens? The frame of reference changes from B to A. That means you are sitting inside A and observing B. Then VBA means what? VB minus VA, where here VB means what? Velocity of B with respect to ground. Okay, so I am just denoting velocity of B with respect to ground, and VA means velocity of A with respect to ground. Okay, I hope that you got the points. Okay, now those who had traveled in trains and all, you know it very well. Why? Because during crossing time, or sometimes you will be sitting inside a particular train and another train is will be moving through the other track, and if they are moving in the same direction, it feels that they are moving slowly, right? That means their velocity decreases. You can see something happens there. The velocity is decreasing. Okay, they're moving slowly. But sometimes what happens is you will be sitting here and the other train will be crossing you. There you can see that one train is moving like this, another train is moving like this. So within seconds, they will just pass. But if you're standing outside and observing the train, then at least 1 minute will be taken for you to count all the bogies. I hope that some of you, at least some of you might have just counted the bogies. Even now, if I'm waiting in a level cruise and all, then I will just count how many bogies are there in the train. So okay, always there is a child in everyone's mind, right? So it's like that. Okay, so there you can see that they are moving or just crossing you within fraction of seconds. So that means the velocities are changing or increasing. So in the first case, you can say it becomes slow. Then the second case, you can say it becomes fast. So why this change? And if you're standing outside and observing both the trains, then you can see that it will be entirely different. So what happens there? So if I'm just taking three scenarios. The first scenario one, in which I am just sitting inside one train and observing the other train which is moving in the same direction. The second case, I am saying that I am sitting here inside one train and observing the second train which is moving in opposite direction. And the third scenario, I am just saying that I will be standing outside and I will be observing both trains. So what happens there? So this is a simple logic. So what is the logic there? In the first scenario where the trains are moving in same direction, what happens there? In the same direction, just imagine that this is train A and this one is train B. So I am sitting in which train? B. So I need to find out which one? The velocity of A with respect to what? B, which is the train in which I am sitting. So B will be the reference point. So VAB is the one which I need to find. So I have to find there. So what happens there? So VAB means what? Velocity of A minus velocity of B. That is, velocity of A means what? With respect to A with respect to ground, where VB means velocity of B with respect to ground. So obviously this will be the case there. So this is a thing which we need to find out. Okay, so there is a minus sign there, right? So there will be a minus sign. So minus sign means just we'll just take some numericals and see. So just imagine the first train which is having 100 kilometer per hour speed, and the second train is having another which is having 50 kilometer per hour speed or velocity. So here what happens? VAB means velocity of A minus velocity of B. Then definitely you can see VAG means what? 100. And this 100 kilometer per hour means, I already said, always the velocities are measured in such a way that the frame of reference will be the ground. So the person who is standing here on the ground will see a speed or see a velocity, and that will be this particular velocity. I hope that you are getting the points there, getting the ideas of the physics story behind this particular scenario. So minus VBG. What is this? So VBG means the velocity of the second train in which I am sitting with respect to the ground, and that is nothing but the 50 kilometers. So 50 kilometers. So what happens there? 100 minus 50, that is 50 kilometer per, sorry, here it is kilometer per hour. Okay, so kilometer per hour. So just see that once the trains are moving, the actual velocity of train A when observed from the ground is 100 kilometers. But if I'm sitting in some other moving frame of reference or this particular point of reference, then I can see the velocity just gradually reduce to 50 kilometer per hour. So here comes the first point, that is if both trains are moving or both frame of reference are moving in the straight direction, then you can see a drastic change in velocity. Why this happens? So this happens because we are dealing with the vectors. So vectors, the directions are very important. So here comes the first point. So what happens at the second point where the two trains are moving opposite? So there the second point moves like this, that is opposite direction. In opposite direction, the same scenario will be taken. So what is this? This one. This will be the frame of reference, right? The second train. So I'm just again saying VAB. That is, A means the first train which is crossing you and which is moving in the opposite direction. The second B train is a train in which you are sitting and observing the first train. That is A. So here what happens? Once again, VA minus VB. Okay, so here what happens? VA means what? A with respect to ground. VBG means velocity of second train with respect to the ground. So what happens? I'm just taking the first, the kilometer of first train, the speed, the velocity of first train as 100 kilometer per hour. The second train is 50 kilometer per hour. What happens here? So here also, the thing is that once I am observing the first train, then I can say the VAG is 100 minus then the second train which is moving. If I am taking the first train's direction, this train's direction as positive. Okay, here the thing is that there is no particular rule that the left side should be negative, right side should be positive, up should be positive, down should be negative. So there is no particular rule, but make sure that we are taking the coordinate system in which we are just having that generalized thing. So we are taking like that. But here in this scenario, I'm just taking that the left side is positive. So the first train is positive. Okay, the first train direction is positive. So I'm just taking 100 minus then BG, in which the second train is moving, which is moving to the right side. So obviously, if I'm fixing one direction as positive, the second direction, opposite direction will be negative. Minus, so VBG will be minus 50. VBG will be minus 50. So this happens there. So minus minus plus, so what is there? 100 plus 50, that is 150 kilometer per hour. Just imagine that. The first train which is having 100 kilometers per hour, once observed from outside or ground, that is 100 kilometer per hour, just increase to 150. Why? Why it is so? The second train is also moving. The second train means the train B is also moving opposite direction. So both the relative velocities comes into play and it just increased to 150 kilometer per hour. So here happens the magic of velocity, of what velocity? Relative velocity, and that is 150 kilometer per hour. Okay, so here the basic thing that you should note is that once a relative things comes into play, what all scenarios or what all credentials will change? The first thing is that the first one is that once the direction comes into play, or once the frame of reference comes into play, then definitely the first and foremost thing is that the velocity will be relative. And the second thing is that the same way the acceleration will be relative. That is, acceleration is also relative. So you can say that way. The direction is also directive, but the direction between, the displacement between the things will be what? It will be fixed. There is no, comparison or dependence on the displacement between 2 points. If I am saying that, okay, this mobile phone and I have a displacement, or between me and this particular mobile phone, this is the distance or displacement. Or if I'm just moving to some other moving object, or if I'm just fixing this particular camera to some moving object or a car, and just I'm shooting this particular displacement. Okay, then also, even though my frame of reference is moving from one point to another, but the displacement between me and this phone will be fixed. And I'm just taking the camera to a rocket and I'm just sending it to the moon, and then I'm just what noticing, or I'm just shooting the me and this particular phone, and I can see that both the person and this particular mobile phone, the displacement is fixed. That means there is no dependence on this particular frame of reference. The same way, one more thing is there, time is independent, so there is nothing to do with time, it will be fixed. And but it is totally independent of the frame of a reference. So these are the things which you need to study while you're studying the frame of reference. So make sure that you should understand that this velocity should be taken with respect to the ground, and that is the first and foremost thing. And frame of reference should be calculated by the observer, or in a way we can say the observer itself is a frame of a reference. So this is how you need to calculate the frame of reference, and you need to calculate the velocity. Which velocity? The relative velocity. So we'll do some of the numericals and see what happens while calculating the relative velocity. Okay, so we'll do some numericals. And so you can see that in the question, that is, you have a train there, and that train is, I'm just naming it as train A, and it is moving with a speed of 50 kilometers per hour. Already it is discussed in the class, right? But still, I'm again explaining this for you. That is again another train which is named as B, and is moving with a velocity of 40 kilometers per hour. Okay, right, 40 kilometers per hour on a parallel straight track. So same direction. So it is already said same direction. What is the velocity of A? Velocity of A with respect to B. And here both the speed or velocities are given with respect to the ground. So there is no issues here. It's a straight question. That is, VAB is nothing but VA minus VB. Actually, it is VAG G, that is with respect to the ground, but we are not writing all these things. Why? Because velocity of ground is taken as 0. So it's 0. There is no special what do you call it, effect in this particular case. So here VAB, or velocity of A with respect to B, is given like this. So VA is nothing but it is 50 minus. Okay, one more thing I want to say. If I'm saying that this direction is taken as positive, then definitely the second train is also moving in the same direction. It is also positive value. You can also take in the other way around. That is, if you're taking this direction as negative, and this one will also be negative. Okay, there is no particular, this positive and negative sign indicates a direction. Okay, as these all are dealing with the vectors, so direction comes into play. Okay, 50 minus, and what happens there? VBG, that is 40, and both are positive, right? Positive. Why? Because I have already taken the first case. That is, I'm taking that the direction in which the train is moving is as positive. Okay, so what happens? 10 kilometer per hour. Okay, 10 kilometers per hour is the thing. That means if I'm saying, okay, VAB means velocity of A with respect to B. So B is the reference point, and you are seeing the train A from B. And you're saying that both trains are moving the same direction, but you feel that this other train is moving with a velocity of 10 kilometers per hour. But its actual velocity is what? 50 kilometers per hour once it is observed from the ground. So what is the vice versa case? That is the other way around. So that is VBA. That is, if I'm sitting here in this first train, and I'm watching the second train, then this will become the frame of reference. Okay, fine. Then what happens here? VBA is VB minus VA. Again, I'm saying both the directions, both the velocities are with respect to the ground. So then what happens? Then VB is what? VB is what? VB is 40. 40 minus, what is there? 50, right? 40 minus 50. And what is that? It is negative 10 kilometers per hour. Okay, here comes the other concept. What is this minus sign? Okay, this is what in the beginning of the class I had just said one thing. That is, once we are small kids, it feels that, okay, if I'm traveling there and many trees are the roadsides are placed in the roadsides, so it feels that the trees are coming towards me, right? Even though I am moving forward, it feels that they're coming backward, right? So the same condition is here. So it is negative 10 kilometers. Why it is so? And the other thing is that VAB is positive 10 kilometers. So here the thing is that VA is what, 50 kilometers, and it is having what, some more velocities than the second train, that is 40 kilometers, right? So it feels that 10 kilometer per hour, it is moving with 10 kilometers per hour. But the other train, which is having 40 kilometers, it is decelerating, right? Or it is having a minus 10 kilometers per hour speed. But it feels that it is moving a bit backward. It is moving a bit backward. Why? Because the train in which I am observing, that is A, which is having higher velocities, it feels that the other train is having lesser velocity than me. That is why it is saying that it is having 10 kilometer per hour. So this is what it is. This negative sign indicates. Okay, fine. You can also find, I'm just giving you my homework, that is, just imagine that this train A is moving in one direction and train B is moving in the other direction, opposite direction. So in this case, what will be the relative velocity of A with respect to B and B with respect to A? This is what you need to find out, and you must give me the answer, and you should give me the answer and pin it in the comment section. So just read the question carefully. A police van is moving on a highway with a speed of 30 kilometers per hour. That means you have a policeman in front of you, right? It's a policeman there. Okay. There's a beacon light. Okay. And this police van is moving at a speed of 30 kilometers per hour. Okay. Then you can see a thief car is there. Okay. And this thief car is moving at 192 kilometers per hour. Okay. Now, you can see in the question, it is saying that a gunshot was done or given. Okay, it has, the police van had given a shot. Okay, then what happens? The bullet is moving towards the car at a speed of, you can see, 150 meter per second. Okay, 150 meter per second. So it is saying that they are asking that at what speed this bullet hits the thief. So we need to just calculate all these mathematical things. Okay, so what we can do? Okay, let us see what happens. So first of all, if you're getting a question, write down all the values given in the question. So first and foremost thing is that speed of a police. So I'm just denoting it as VP. And I already explained and said that all the velocities are taken with respect to the ground. So VP, in fact, it is saying that VP with respect to ground. Okay, VPG is the actual thing. That means VP minus VG, and the ground's velocity is 0. So you can see that VP is denoted as VP, G is denoted as VP itself. Okay, so I'm not writing all this VP minus VG and all. Okay, it's itself. Okay, fine. Okay. So now I'm saying that Vp is equal to 30 kilometers per hour. Okay. And the second one is that Vt, and it is given as 192 kilometer per hour, right? 192 kilometer per hour. And it is the last one is Vb, and it is given as 150 meter per second. So you can see that one is meter per second and other twos are kilometer per hour. So make sure that you calculate this thing into meter per second. And that is 30 into 5 by 18. You all know that thing. Okay, you can just cancel by 6. So you can say 6, 5, 5, 25 by 3. Okay, meter per second. I'm just putting it in the fractional form. And 192 into 5 by 18. Here also you can divide by 6. Okay, yes. So 6, 3. Okay, so this is, okay, 6 if you're just cancelling, then 3, 32. Okay, 32 into 5 by 3, and that is nothing but 5, 10. Okay, and 1, 15, 60, 160 by 3. So this is the thing, that's meter per second. and the last one is 150 meter per second. Okay, and here one small concept is there. What is actually said? What is speed does the bullet hits the thief's car? This is what we need to find out. And at what distance or what speed the bullet hit the thief car means velocity of the bullet with respect to thief. This is what you need to find out. And you all know that velocity of bullet with respect to thief is VB minus VT. This is what we need to find out. But here one issue is there. What is that issue? That is VT is given there and VB is not actually the B which is given. Okay, so what is given there? What is this 150? This is what I need to just ask you, or I'm just asking you, what is that 150? So if the muzzle speed of the bullet is 150, that means you already know that an object is moving, means the policeman is moving and the bullet is also moving. Both the things are moving, right? So here the 150 is not actual speed of the bullet. Why? Because here comes the relative velocity. You already know that already the police van is moving at a speed of, what is that, 25 by 3 meter per second. So you need to add up both velocities. Why is it so? Why? Because both the objects are moving in the same frame of reference. Both are moving. So we can say that the actual velocity of the bullet with respect to ground is given as VB plus VP. That is the given value, that is 150 plus, what is that? What is the bullet, this police van's velocity? That is 25 by 3. So from there you will get what? You will get, that is 450, it is 450, 475 by 3, 475 by 3 meter per second. Okay, this is the velocity of bullet with respect to ground. So now coming to the point, what is the actual bullet's velocity with respect to the thief? So here you can see that VBG minus VTG, and here what you have found out, VBG, that is 475 divided by 3 minus, what is VTG? VTG, that is 160 minus by 3, 5 meter per second. That means the bullet hits the car at a speed of 105 meter per second. It is not actually 150 meter per second, it is 105 meter per second. So here all the main issue is that we need to consider the relative velocity. If you're not considering the relative velocity, you will not get a correct answer. So that's it for today's class. So I hope that you got the points, and keep practicing, and then we'll meet in the next class with new topics for the class 11, and new chapters are also starting there. So keep supporting like you're supporting till now, and then we need your support, more support in terms of your like, share, comment and subscription. Till we meet again, goodbye and have a nice day.